NFPA 101, the Life Safety Code, mandates emergency lighting in specific occupancies to ensure safe egress during power failures. Having an emergency light on a separate circuit from the interior lighting is indeed permissible and a common practice to bolster safety measures. The fundamental rationale for this design lies in the necessity for emergency lighting to operate independently of the normal power supply. By isolating the emergency lighting circuit, its functionality remains intact even if the primary power source is disrupted. In a communication shelter setting, the separation is crucial. Should a power outage occur, occupants can rely on a dedicated emergency lighting to guide them to safety. Several factors dictate the specifics of emergency lighting system design and installation. Firstly, the Life Safety Code details the types of occupancies that necessitate emergency lighting systems. These typically include assembly areas, educational facilities, healthcare occupancies, and various other locations where a significant number of people congregate. Secondly, the code stipulates the minimum illumination levels required for emergency lighting. These levels are calibrated to provide sufficient visibility for safe egress without causing undue glare or disorientation. Thirdly, the Life Safety Code sets forth the duration for which emergency lighting must be sustained. Typically, emergency lighting systems are designed to provide illumination for a minimum of 90 minutes following a power failure. This duration ensures that occupants have ample time to evacuate the building safely. Fourthly, emergency lighting systems must undergo regular testing and maintenance to verify their operational readiness. These tests involve simulating power outages and confirming that the emergency lighting activates and functions as intended. Fifthly, the placement of emergency lighting fixtures is strategically planned to illuminate critical areas such as exit routes, stairwells, and corridors. The fixtures are positioned to provide uniform illumination and minimize shadows that could impede egress. Sixthly, emergency lighting systems can be powered by various sources, including batteries, generators, and uninterruptible power supplies, also known as UPS. The choice of power source depends on factors such as the size of the building, the criticality of the occupancy, and the available resources. In the context of a communication shelter, the use of a separate circuit for emergency lighting offers several distinct advantages. Firstly, it enhances reliability. By isolating the emergency lighting from the normal power supply, the risk of a common mode failure is reduced. This means that a problem in the normal power circuit is less likely to affect the emergency lighting system. Secondly, it simplifies maintenance. With a separate circuit, troubleshooting and maintenance of the emergency lighting system can be performed without disrupting the normal lighting. This reduces downtime and improves the overall efficiency of the facility. Thirdly, it improves safety. By ensuring that the emergency lighting remains operational during a power outage, the risk of accidents and injuries is minimized. This is particularly important in a communication shelter where occupants may be working with sensitive equipment or in confined spaces. The National Electrical Code, or NEC, also addresses emergency lighting systems. While the NEC focuses primarily on the electrical installation aspects, it complements the Life Safety Code by providing detailed requirements for wiring, overcurrent protection, and grounding of emergency lighting circuits. NEC Section 700 covers emergency systems. NEC Section 700.12 details permissible power sources for emergency systems, including generators, storage batteries, and UPS systems. NEC Section 700.16 addresses the illumination levels required for emergency lighting, referencing the Life Safety Code for specific requirements. NEC Section 700.26 outlines the testing and maintenance requirements for emergency lighting systems, emphasizing the importance of regular inspections and functional tests. In designing and installing an emergency lighting system with a separate circuit, several key considerations come into play. Firstly, the circuit must be properly sized to accommodate the load of the emergency lighting fixtures. This involves calculating the total amperage draw of the fixtures and selecting conductors and overcurrent protection devices with adequate capacity. Secondly, the circuit must be wired in accordance with applicable codes and standards. This includes using approved wiring methods, ensuring proper grounding, and providing adequate protection against physical damage. Thirdly, the circuit must be clearly labeled as an emergency circuit. This helps prevent accidental disconnection or modification during normal maintenance activities. Fourthly, the emergency lighting fixtures must be selected and installed in accordance with the manufacturer's instructions. This ensures that the fixtures operate safely and reliably and that they provide the required illumination levels. Fifthly, the emergency lighting system must be integrated with the building's fire alarm system. This allows the emergency lighting to be activated automatically in the event of a fire, providing occupants with a clear path to safety. In summary, having an emergency light on a separate circuit from the interior lighting is not only permissible but also a recommended practice to enhance safety and reliability. The Life Safety Code and the National Electrical Code provide comprehensive guidance on the design, installation, and maintenance of emergency lighting systems. By following these codes and standards, building owners and facility managers can ensure that their emergency lighting systems are ready to perform when needed, providing occupants with a safe and well-illuminated path to egress during a power outage. Moreover, consider the types of emergency lighting technologies available. Light-emitting diode, OLED, fixtures are becoming increasingly popular due to their energy efficiency, long lifespan, and instant-on capability. LED fixtures consume significantly less power than traditional incandescent or fluorescent fixtures, reducing the overall load on the emergency power source. Their long lifespan minimizes the need for frequent replacement, reducing maintenance costs. The instant-on capability ensures that the lights activate immediately upon a power failure, providing immediate illumination. Battery backup systems are a common power source for emergency lighting. These systems typically consist of a rechargeable battery, a charger, and an inverter. The battery stores electrical energy and provides power to the emergency lighting fixtures during a power outage. The charger maintains the battery at full charge, ensuring that it is ready to provide power when needed. The inverter converts the direct current, or DC voltage, from the battery to alternating current, or AC voltage, to power the fixtures. Generators are another option for providing emergency power. Generators are typically used in larger facilities where a significant amount of emergency power is required. Generators can provide power for extended periods of time, ensuring that the emergency lighting remains operational until the normal power supply is restored. However, generators require regular maintenance and testing to ensure that they are ready to operate when needed. Uninterruptible power supplies, also known as UPS, provide a seamless transition to emergency power. UPS systems are typically used to protect sensitive electronic equipment from power outages. However, they can also be used to power emergency lighting fixtures. UPS systems provide power instantaneously, ensuring that there is no interruption in illumination during a power failure. When selecting emergency lighting fixtures, it is important to consider the illumination levels required by the Life Safety Code. The code specifies minimum illumination levels for various areas, such as exit routes, stairwells, and corridors. The fixtures should be selected to provide adequate illumination in these areas, ensuring that occupants can safely evacuate the building. It is also important to consider the color rendering index, also called CRI, of the emergency lighting fixtures. The CRI is a measure of how accurately a light source renders colors. Fixtures with a high CRI provide more accurate color rendition, making it easier for occupants to identify objects and navigate the building. The placement of emergency lighting fixtures is critical to ensuring effective illumination. The fixtures should be positioned to provide uniform illumination and minimize shadows. They should be located in strategic areas such as exit routes, stairwells, and corridors to provide a clear path to safety. The fixtures should also be installed at a height that provides adequate illumination without causing glare. Regular testing and maintenance are essential to ensure the operational readiness of emergency lighting systems. The Life Safety Code requires regular inspections and functional tests of emergency lighting systems. These tests should be performed in accordance with the manufacturer's instructions and documented for record-keeping purposes. The test should verify that the emergency lighting activates upon a power failure, that the illumination levels are adequate, and that the batteries are fully charged. Maintenance activities should include replacing batteries as needed, cleaning fixtures, and repairing any damaged components. Detailed documentation of the emergency lighting system is essential for ensuring compliance with codes and standards and for facilitating maintenance activities. The documentation should include a system schematic, a list of components, testing and maintenance records, and contact information for the system installer and maintenance provider. The documentation should be kept in a readily accessible location and updated as needed. Furthermore, consider the integration of emergency lighting with other building systems. Integrating the emergency lighting system with the fire alarm system allows the emergency lighting to be activated automatically in the event of a fire. This ensures that occupants have a clear path to safety, even if the power has not failed. Integrating the emergency lighting system with the building management system, also called BMS, allows for remote monitoring and control of the system. This enables facility managers to monitor the status of the emergency lighting system, perform remote tests, and receive alerts in the event of a failure. In conclusion, providing emergency lighting on a separate circuit from the interior lighting is a vital safety measure that ensures reliable illumination during power outages. The Life Safety Code and the National Electrical Code provide comprehensive guidance on the design, installation, and maintenance of emergency lighting systems. By following these codes and standards and considering the latest technologies, building owners and facility managers can create emergency lighting systems that provide a safe and well-illuminated path to egress for occupants during a power failure or other emergency situations. Remember to consult with qualified electrical engineers and contractors to ensure that the emergency lighting system is properly designed, installed, and maintained. They can provide valuable expertise and guidance on selecting the right components, complying with applicable codes and standards, and ensuring a long-term reliability of the system. Lastly, keep abreast of the latest developments in emergency lighting technology. The field of emergency lighting is constantly evolving, with new technologies and solutions emerging regularly. By staying informed about these developments, building owners and facility managers can ensure that their emergency lighting systems are up to date and provide the best possible protection for occupants. For example, consider networked emergency lighting systems. These systems use wireless technology to connect the emergency lighting fixtures to a central control panel. This allows for remote monitoring and control of the system, as well as the ability to perform automated tests and generate reports. Networked emergency lighting systems can also provide valuable data on energy consumption and system performance.